Hello students, in our previous video we had discussed about the basics of circle. Now in our today's video we are going to prove a theorem that is based upon a circle that equal chords subtend equal angles at the center of circle. Now before proving this theorem I'll tell you that when do we say that a chord subtend an angle at the center of circle. For example, let's say we have a circle O, right, and this is the center of circle. Sorry, this is circle and we have a center O of a circle, right? Now let's say we have a chord, this chord AB. Now what I've told you about a chord is a line segment that connects 2 points, any 2 points on a circumference of circle, right? So these are any 2 points and this is a chord that is connecting 2 points AB. Now AB is a chord that now if you join OA and if you join OB. Now you can see if I join OA and OB, you can see that an angle is being formed, angle AOB, right? This angle is called angle subtended by that chord AB on center of circle, right? So angle AOB will be called angle subtended by the chord AB on center of circle. Now what we have to prove? We have to prove that equal chords subtend equal angles at the center of circle. So let's say we have chord AB. Now let's say we have another chord CD here, which have length equal to AB, right? Now if I join D and OD and OC, this is also an angle. Now this is the angle subtended by the chord CD at the center of circle. Now we have given in this theorem we have given that equal chords subtend equal angles, right? So we have given that AB and CD are equal chords. Now what we have to prove? We have to prove that these angles, angle AOB is equal to angle COD, right? So first we write what we have given. Now we have given in this circle, the center O, in a circle with center O. In a circle with center O, we have given that AB and CD are equal. That is AB equals to CD. So these chords are equal. Now what we want to prove? We want to prove that angles subtended by these chords, equal chords, that is angle AOB is equal to angle COD. This is what we want to prove. Now let's try to prove. Now we'll prove this theorem by, you must be familiar with the term congruency, right? Now we'll prove this theorem by congruency. Now what is congruency? That two triangles are congruent if they have same side of the same length of sides and same angles, right? Now you can see that two triangles are being formed inside this circle. Now if I prove these if these triangles are congruent, right, then by simplicity these angles will be equal. Simplicity means corresponding parts of congruent triangles, right? If two triangles are congruent, right, so there if I prove two triangles are congruent, so by simplicity their all sides and all angles will be equal, right? Now you can see these two triangles. If I prove these two triangles are congruent, then by simplicity I will be able to prove that these angles will be equal. So let's start. Now in triangle AOB and triangle COD, these are two triangles that are being formed, right? Now first of all, which sides of this triangle will be equal? You can say this OA and OC. Why they are equal? Because they are what? Radii, right? Radii of a circle is equal. I have told you that radius is a fixed distance from center to the any point on a circumference. So OA equals to OC because of radii. Similarly, OB will also be equals to OD. They are also the radii of a circle, right? So OB equals to OD. Reason same, radii of a circle, right? Also, we have given that AB and CD are equal length, right? So AB and CD are equal. So AB equals to CD. This is also we have given. Now you can see three pair of sides are equal. So by SSS criteria, by side criteria, triangle AOB will be congruent to triangle COD. Now these triangles are congruent. So by simplicity means corresponding parts of congruent triangles. By simplicity, angle AOB will be equal to angle COD. Right? Proved? This is what we want to prove, right? So equal chords subtend equal angles at the center of circle. Now what if I ask you, is converse of this theorem true? if I say that if these angles are equal, angles present by two chords at the center of circle are equal, will those chords will be equal? That we'll discuss in our next video. So if you have any query regarding this theorem or any query regarding mathematics, so do make sure to contact me. I'll give my number below. Thank you, students.